Yeah, hi. How you
Hey, how are
doing?
you doing? I'm good. I'm good. How are you doing?
I'm great. It's great talking to you.
Yeah, of course.
Uh, so I was just wanted to get to know about like your journey and how you started and got into AI and CS and stuff like that. So
Yeah, I can talk a little bit about that. So I guess to start, I'm Naveen. I'm currently a PhD student. I'm a first year. I went to undergrad at the University of Maryland, spent a year at Cambridge doing like a 1 year master's, and now I'm up at Carnegie Mellon in Pittsburgh. And so yeah, the way I started in CS, I started doing research when I was in high school. I worked with a few people at Maryland when I was one of the summers, I think 10th grade summer, something like that. And so that's how it really started. I worked on like a simple kind of problem. It was like a combinatorics style kind of little bit of CS problem. And so it gave me kind of, it really threw me into like, oh, what is research? What kind of things do I have to do? And so from there, I really started doing more research as an undergrad. And so one of the first projects I worked on as an undergrad was with two people, with Arvind Srinivasan and Max Leiserson. And what we did is we worked on computational biology things. Basically, what we wanted to see is in cancer, you have these things called mutational signatures, which basically underlie every kind of cancer. And so the question is kind of, can you detect what kind of mutational signatures exist computationally? And so what this means on the ground is when you're given a bunch of like mutation data,
mhm.
you apply like matrix factorization algorithms to say, okay, this kind of signature, which represents these kind of specific deletions and additions and whatnot, is present at this intensity. This one is present at this intensity, things like that. And so you can kind of see that these signatures correspond to real world things. Like, for example, there's a signature that corresponds with UV radiation, with kind of cigarette smoking and things like that. And so that's, I would say that's the first time I did like a machine learning style thing. It was pretty cool. So I think both of my advisors left to do other things for like a year or something. So I was left without a project. And so during that time, I stepped into two kind of new projects, which were very, very like ML, NLP, AI
Sure.
focused.
Hmm.
And so that's how I got into this. I worked with John Dickerson at UMD on rideshare kind of fairness, looking at can we do matching algorithms in kind of rideshare between riders and drivers to make the kind of matches more fair, both on the rider side and the driver side. And with a person named Jordan Boyd Graver, I worked on kind of natural language processing, looking at something called entity linking, basically saying if I have a sentence, can I link kind of the nouns in this sentence to their Wikipedia pages? How do you collect data for this? How do you evaluate this? Things like that. So I was looking at this more from the data collection NLP side. And so it was interesting kind of working on these two projects, looking at kind of two different sides of AI. And so really it all started from high school, just working on CS research and just trying out different research projects and seeing what I was interested in.
So you started like in the combinatorics field, sort of like the math aspect of it, and then migrated over to CS, that kind of stuff.
So I started out, it was like a CS combinatorics kind of in between. I would say a lot of the projects I did, I just saw something cool and I wanted to do it. There was no
Mhm.
kind of intention of like, oh, I want to work in this field. I want to do this.
Sure.
It was mostly whatever's available is what I do. And so I would say it's partially just by chance that I ended up in ML and whatnot. I could just have ended up in biology or
Hmm.
comp bio or I don't know, security or some other part of
Yeah, of
CS.
course.
So it's just mostly kind of a circumstance of what I've been kind of working on.
Hmm. Why do you think it's important for high schoolers to get interested in research, or why do you think research is important in general?
Yeah, I think research is really cool because I think research teaches a lot of really cool things that you don't typically get in your education. I think one of the biggest things with research is that you're tackling these problems that are just fundamentally unknown. And I think learning to deal with this kind of unknownness, learning to deal with like, oh, I don't know anything, I really need to learn a lot, I think is always a good thing to learn. I think research also kind of puts you on the cutting edge of things. So you learn a lot by the process of doing research, by seeing what works and what fails. And you kind of get an idea for like, oh, why did a particular field progress in the way it did? And I think it's just good. It's just a good way to train in the sense, right? In the sense that like you're grappling with really hard questions, you're grappling with kind of really cutting edge things. And I think that's just good for development in general.
Yeah. So you mentioned that you got involved in research at a really young age. What drove you to start getting interested in that kind of stuff?
So, I mean, really what drove me is that I had a summer and I was like, oh, I got nothing really to do during the summer. So
Yeah,
I'm like, okay, I might as well try doing research at my local
sure.
undergrad. And I knew some other people who did that before. So I just reached out to a few professors, seeing what was up. And then from there, it just kind of went from there.
Nice. Um, so what are you like what generally are you working on as of now? Because I know you mentioned about like computational biology and a lot of different topics in CS and
Mhm.
so what are you like working on now?
Yeah, so what I'm generally interested in now is like multi-agent decision making. And what that really means is that in a lot of kind of real world scenarios where AI might be useful, there's a lot of different like human or AI agents at play. And this really complicates things. For example, when you have a lot of humans at play, for example, in rideshare, making decisions is complicated because each of the humans is strategic in a sense. Humans say, oh, I don't want to be matched to this driver. Oh, I have these incentives. How do you make decisions under this? And so humans are also heterogeneous. They have different preferences, different kind of attributes. How do you make decisions under this kind of circumstance? And the third thing is that humans are generally uncertain. It's not just that humans are uncertain, there's a lot of kind of information that's kind of random, stochastic, things like that. So how do you make decisions under that? And so what I'm really working on right now is a project in what's called food rescue. And what that means is that there's kind of like little startups in Pittsburgh that transport excess food from things like food from restaurants, things like that, to places that need them, like food banks. And so the challenge I'm working on right now is saying these kind of the transportation of this is done by volunteers. And the question is like which volunteers should we notify for which kind of food rescues or food trips,
Sure.
with the kind of constraint that notifying too many volunteers leads to kind of burnout. And also with the constraint that you want to make sure that these trips are answered by someone. You want to kind of prioritize the right people to ask for this, while noting that these people might have preferences. For example, one volunteer might be like, oh, I want to only do things that are nearby within a 1 mile radius. So keeping that in mind underneath all these constraints, how do you determine which volunteers to optimally notify so that you can manage both the volunteers and the actual food deliveries?
So can you like briefly explain like one way you found that you can like algorithmically or like using AI or something like that, take into account all the different human preferences and make a decision, something like that.
So right now I'm actually working on that. It's not far enough that we actually have algorithms to do this yet.
Hmm.
I think it's definitely challenging. Of course, one of the first things you have to do in research is just make a baseline. So you could just say, oh, just notify everybody or
Hmm.
notify nobody, things like that.
Yeah.
And so what we're trying to see right now is like, can we learn kind of use like what is called like bandit algorithms or reinforcement learning to say, if I notify this person, what is the kind of long-term reward I get versus if I don't notify them, what do I have a kind of constraint on how many people I can notify?
Mhm.
And so it's this question like, how do we take into account the kind of reward signals we get in kind of like a simulated environment to learn over time who to notify and who not to notify?
So, how would you like sort of double check decisions made by those algorithms? Like, I saw on your website another thing that you were looking at was like human double checking or validation of
Yeah.
such algorithms. So how would you go about doing stuff like that, or does that relate to what you're doing? As you said that we're not as advanced to have such AI algorithms to do that kind of things yet. But
Yeah.
how'd you go?
Yeah. So I think decision making with these kind of human factors is very important. I think one of the big things is just making sure, like for a lot of things, especially in high risk scenarios, you always want some kind of human in the loop. For example, if you have a kind of AI ML thing in the hospital, what you really want, and what's happening right now, I think, is that generally the AI isn't making decisions by themselves. Normally, there's kind of a doctor in there where the AI presents a decision, and the doctor's like, "Yep, that checks out with what I think." So most of the time, right now, ML and AI uses kind of like a double checking mechanism. In some scenarios where it's not as high risk, where you can kind of afford to make mistakes, you can do these things automatically. But even then, you want some kind of recourse to say, "Okay, this was a mistake. Why did you make this mistake? How can we go back and fix it?" And so I've worked on things related to that in some sense with kind of my work on interpretability, which basically asks like why do models make certain predictions, decisions, things like that. And so it tries to make kind of the black box of these big models more kind of understandable by humans.
So uh and these are implemented in like hospitals or some medical situations for the interpretability type thing.
So interpretability, I think, is a general paradigm where you want like models to be understood. I think in a lot of settings, like for example, hospitals, at least before they really wanted interpretability, they were like, if we're going to push out ML models here, we need these models to be interpretable. That's the only way we're going to push them out. And so it's just a general kind of desiderata across many scenarios where if you're going to deploy ML to important scenarios, you want kind of a B course action, you want interpretability so you can understand why things kind of decided in the way they were.
Mhm. And as the state of such algorithms or models improves, do you think the role of humans in checking those out, or I think at this point humans don't really check the algorithms, humans just check what they think with the algorithms. Um, but do you think as those models improve, the role of human robot interaction will change?
So I'm not really sure. That's a good question. That's a very good question. It's not something that I know that much about, I'll say. I would figure it does change over time as these models become more complex or more interpretable or whatnot. But to say how they'll change, I can't tell you. That's something that's definitely outside of my expertise.
And so have you had experience? You probably had experience making such models, right? In working with those kinds of
So I've definitely worked with like
decisions.
large models. I've never deployed a model so far because deployment in machine learning is a very challenging thing.
Sure. Hmm.
But I've definitely worked with like big models and kind of big architectures and whatnot.
Hmm. And have you at least like, so in the news, there's a lot of talk about like bias
Mhm.
in such models, and especially in terms of medical situations, bias is definitely an important thing to account for. And have you ever encountered these, and what are your thoughts on that? And
So yeah, bias is a very interesting thing. I think in general, like for a model, the quality of a model is only as good as its data. So if you give it a lot of biased data, then the model itself will be biased. And the bias can be something very, very basic. Like there's a data set where you have pictures of birds in different environments. And so some birds are only taken over water and some birds are only taking pictures over land. And so in a sense, this kind of biases the model itself. So you're saying, okay, the model will kind of resort to using shortcuts to say, okay, I see that there's a background of water. It's probably one of these birds, even though the kind of attribute of water doesn't impact what the bird itself is. So I've definitely seen lots of examples of this kind of thing, and it's an active area to see how do you debias these models, how do you debias the data sets. And in language, for example, you could see that GPT might have certain biases, and that's one of the big things to see. How do you make sure LLMs give good responses, aren't biased, and things like that? So it's definitely like an active area of research.
um, and then about you, like, what do you think you're most proud of, like, in the research that you've done so far?
I don't know. That's a tough question. I think it's generally doing research and kind of learning about these different topics I'm proud of. I think
Hmm.
it's always tough at the beginning of a research project to learn, like, oh, how do you do this? How do you do that? Because you're still new to a field. And I think just getting to the point where you understand the field, you can read the papers is always an accomplishment. And I think that's pretty cool.
And so, for students like us, how would you, um, recommend navigating such a complex environment if we're interested in getting started with research?
Yeah, I think for research, what I would definitely recommend is like, you want to talk to the professors at whatever local university might be nearby. I think talking to them is always a good thing. And I think the big thing is that you want to read their research before you email them, just kind of get a feel for like, this is what they do. And I think one of the things is also just trying to learn as much as you can, right? If you want to do research in AI or some kind of subfield of AI, then trying to learn from the basics, like what does this do? What is the math behind it? I think math is also very important. Just kind of
Mhm.
picking up as much math as you can, both in undergrad and in high school, is always going to be helpful. I think I still try to learn as much math as I can because I think it always comes up that I need more math for something.
Mhm. So when I think about AI and when my classmates think about AI, we think about like coding and stuff, but I've heard that AI is also very mathematical, like you were just saying. What'd you
Coding,
say
yeah,
about
I
that?
would say it's almost all mathematical because I think a lot of the models are built on math to say, oh, this is what we want from the model. This is how we kind of design the algorithms to do this. And like for example, if you're gonna like taking a step back from AI, like the AA that you guys think of, like in a lot of scenarios, you might design like algorithms that do some kind of task, but do it randomly, right? You'd say,
Mhm.
oh, if I do this with some amount of randomness, I'll achieve what I want in pretty fast speed.
Mhm.
And so to do that kind of thing, you need a lot of like probability theory to say, okay, with like probability this big, I'm going to achieve what I want with this likelihood. And so that's just a basic example of like where kind of math or statistics and kind of AI intersect. Of course, there's a lot of coding to say, oh, this is how I implement things, but I don't think the difficult part of AI is ever the coding. I think most things where you have an idea for how to do this, if you know how to do something, you can code it up without that much difficulty. I think the difficult part is coming up with the ideas and either like proving that it works or just thinking of like a good experiment to show that it works. So I think it's more about, I would say it's more about either the math or the problem solving more so than just the coding skills.
So you talk about multi-agent systems as the
Yeah.
current field that you work in.
Uh,
How would you what do you think the future of your current field is right now?
I'm not sure. I think one thing that I saw a talk on yesterday was using foundation models for like these big models in reinforcement learning and trying to see can we
Mhm.
develop like larger models in reinforcement learning that can generalize better. And I think that's always a challenge. It's like developing more general things that work on multiple situations. So seeing if we can generalize, we can develop algorithms that work across multiple multi-agent systems or multiple kind of game theoretic systems, things like that. I think that's always an interesting thing. And always trying to connect it more with practice, trying to see what is the people in practical applications see and how do we address that.
And so is multi-agent systems like I don't think I understand fully like what multi-agent systems is. Seems like a really complex topic. Like, is it centralized to like only computers, or is there aspects of it in like robotics and different stuff like that?
So I think it depends on who you ask. When I say multi-agent, I'm referring to I think I'm intentionally being broad, just saying like, oh, we have multiple robots or humans or AI or whatnot. And just I think the interesting thing is just generally like coordinating different actions and taking into account preferences and heterogeneity and whatnot. I think if you ask like a robotics person what multi-agent means, they might talk about multiple robots. I think if you ask a game theory person, they'll talk about different agents or humans. I think there's definitely like a lot of different kind of things at play there. And I think I don't know if there's one good definition.
Okay. Um, it was really great talking to you. I really
Of
appreciate
course, yeah.
all the insight that we got from this. Have a nice day.
Too, man. Let me know how everything goes with that.
Yeah, awesome.
Sounds
Thank you
good.
so
Yeah.
much.
Cool. See you.
See ya.